Hi everyone, welcome to Integral Calculus. Today we explore lesson 5.4, the net change theorem. Number one, the net change theorem. We know integration is the antiderivative, so we integrate f prime x dx from a to b, then this would be fb minus fa. Let's take a look at how we use the theorem. Example 1. A motorboat stopped at time t equals 0. It consumes gasoline at a rate of 5 minus t to the power 3 gallon per hour. How much gasoline is used in the first 2 hours? Rate right here is f prime t, 5 minus t to the power 3. Gasoline used in the first 2 hours, that is integral from 0 to 2 f prime t dt. We just integral from 0 to 2 5 minus t to the power 3 dt. Antiderivative of 5t, antiderivative of t to the power 3 is t4 over 4. Now do the substitution and we have 5 times 2 is 10. 2 to the 4th 10 divided by 4 is 4. When we sub in 0, we get 0. The answer is 3. Example 2. According to a record, a small town population began with 250 people. The population grew at a rate of p prime t equal 30 times 1 plus square root t, where t is measured in years. Find a model for the population pt at time t. We are given the rate. We can use the net change theorem and it say that pt minus p of 0 is integral from 0 to t. The rate p prime, I'm gonna use x there, dx. So pt is p0 plus integral 0 to t 31 plus square root x dx. Pretty cool, huh? And this would be p sub 0 is the initial population, so that's 250 people. And this one, just have to find the antiderivative. Antiderivative of 1 is x 30 x. Antiderivative of root x is that is x to the power 1 over 2. So plus x 1 over 2 plus 1 over 1 over 2 plus 1. And evaluate this from 0 to t. So we have 250 plus, we can take out the number 30 x, okay. 3 over 2, so it's going to be a 2 over 3 x 3 over 2, 0 to t, 250 plus 30, sub in t for x, so t plus 2 over 3, t 3 over 2. And then when we sub in 0, we just get 0. Okay. So we have 250 plus 30 t and plus 20 t 3 over 2. Two, distance travel and displacement. Imagine a car speeding on a road. So we have t for time and vt for the velocity. The car begin to speed up at t equal to 0. And it travel a distance. Then it want to make a U-turn. So to make a U-turn, it has to slow down and then make a U-turn. When it run to the opposite direction, the velocity is gonna be negative. So the graph would look like this. That is the graph of VT here. We see that for a time from t sub 1 to t sub 2, we get two area. The area above the x-axis is positive. We also have the area below the x-axis is negative. So in order to get the distance travel, we got to add the absolute value of the two areas. Distance travel. Well, to get the absolute value, we do the integral from t1 to t2, absolute value of the velocity and displacement. Remember, the car run for a distance and then it U-turn, it go back. So the displacement is somewhere in between the starting point and the U-turn. For the displacement, it's going to be the positive area plus the negative area. And that is exactly the integral from t1 to t2 of vt dt. Very different distance travel and displacement. Okay, let's take a look at an example. Example 3, a particle had velocity vt equal to t squared minus t minus 6 recorded during the time period from t equal 1 second to t equal 4 seconds. A, find the displacement of the particle during the time period. B, find the distance traveled by the particle during that time period. Okay, now let's sketch a graph of this one here. And then we take a look at the graph. We have a t and vt. Okay, vt is a parabola, t squared minus t minus 6, meaning that we can factor this out to be t minus 3, t plus 2. So we have two x-intercept, one is equal to 3 and then the other one is negative 2. So we have 3 minus 2, and this is what the parabola look like. We want the time from t equal 1 to t equal 4. Somewhere it has 1 and 4. If you take a look, then yes, one area is below the t-axis, the other one is above the t-axis. Now we can do A, because we have the graph. Displacement is integral from 1 to 4 of vt dt, which is the integral from 1 to 4 t squared minus t minus 6 dt, and that is t3 over 3 minus t squared over 2 minus t, evaluate from 1 to 4. So we have a 4 to the power 3, 64 over 3 minus 4 squared 10 divided by 2 is 8 minus 10 4 is 24. Now plug in the 1 over 3 minus 1 over 2 minus 6. 64 over 3 minus 1 over 3 is 63 over 3 minus 8 minus 24 is minus 32 minus is plus 1 over 2 and minus 1 is 7 plus 6. So we have a 21 minus 32 plus 6, that would be 27 minus 32 negative 5 plus 1 over 2, and that gives us negative 9 over 2. Wow. Now let's take a look at the distance travel. Distance travel is integral 1 to 4 absolute value of velocity. Well, we have two areas, one below the t-axis and the other one above the t-axis. The area below the t-axis is the integral from 1 to 3 t squared minus t minus 6 dt. The integral is negative, so we need to negate the negative to get a positive. So put a negative in front of the integral. Next area is from 3 to 4. So 3 to 4 t squared minus t minus 6 dt. Yay! Let's evaluate this. Negative t3 over 3 minus t squared over 2 minus t from 1 to 3 plus t3 over 3 minus t squared over 2 minus t evaluate from 3 to 4. It's going to be a lot of fraction. Very useful if you have a small calculator. I'm going to distribute the negative in here, make it a little less clunky. So we have a 3 cube over 3, so 3 square, right? Negative 9. Minus is the plus. 3 squared is 9 over 2. Minus the plus times 3 is 18. Okay. Minus, sub, put the number 1 in. The minus and this huge minus, they're going to cancel out. Okay. So it's going to be minus there. Without doing the distribution. 1 over 3 minus 1 over 2 minus 6. On the other side, we have 4 to the power 3. That's 4 over 3. 4 square, 16 over 2, that's 8. And times 4 is 24. Okay, minus, plug in number 3. So that's be 9 minus 9 over 2 minus 18 times 3 is 18. Okay, so plug this in the calculator and that should get us 61 over 6. Okay, thank you for watching. I hope you like the content of the video. Please like and subscribe to help the channel growth. I'll see you in the next video.